Hi everyone again. My name is Tatiana Sennikova, and today we have been talking already a lot about predictive analytics and how we can utilize it for our projects. And I will talk about the prescriptive analytics and how we can advise to our clients how to take better decisions with it. A little bit about me. I'm working in Publicis Sapient, and I have 5 and more years in machine learning and data analytics, and I came to this area from software development. My focus is production-ready machine learning models, and in Publicis Sapient we develop a lot of projects with the key components in machine learning, deep learning, natural language processing, and we also develop recommendation systems. And shortly about Publicis Sapient. Publicis Sapient is a digital transformation partner which belongs to Publicis Group, and we have 20,000 employees across the world in 50 different offices. And our clients are from consumer products till automotive industry, so from different industries. So what I will be talking today about, that will be a little bit about prescriptive analytics and what it is and how we can utilize it for our purposes. And then I will show you a case study with one of our clients from Automotive. But first, let's define what actually is prescriptive analytics. So first, as we already been discussing, there is this first step, which is a big and very important, which is a predictive analytics. And what predictive analytics does, it provides us insights. It answers the questions what, when, why will happen. But when we answer these questions, we actually don't know how to act. Yeah, so we need to make some decisions, and we need to evaluate how these decisions will impact the environment around us and our project. So, and that's exactly the questions that prescriptive analytics is tackling. And a recent example of how the prescriptive analytics have been used and where it was useful comes from India, from the city Odisha, when a year ago a deadly storm was coming, but because the meteorological department have already had the forecast that there will be a storm, there was no loss in life. Yeah. In contrast, in 1999, like 10 years before that, 10,000 people died because of exactly the same storm been coming before. But this time, since the government have already had this forecast, they could make this decision that would have saved lives. And that's a very nice example how the prescriptive analytics can help us in making our decisions and why it's important. But now let's go to more business-related problem, to our automotive client. And what is interesting about the automotive industry and automotive clients, when they sell a car, quite a big part of the revenue that the company is getting back is spent for media and for the dealer incentives to kind of steer the selling process. And so it could add up to 33% of the revenue that the OEM gets from the car being sold. And that's actually an opportunity for us to optimize this spends. And why is it so? Because if we save, for example, just 1% of incentive and media spends, then it will translate in 80 million euros saved per year. And that's a lot of money, of course. So how we do that? We do this savings through the optimizing of sales funnel. And by sales funnel, I mean the whole funnel, whole journey of the customer from the very first time when the customer landed on the website till his specific actions that he does there, for example, creating a car configuration or scheduling a test drive, and then he might go to the dealership and get their offer and finally buy a car. So that's quite a long journey. And we need to understand how many people we have on each step of the journey and what are the factors which influence that. And that's where we can utilize machine learning for this purpose and get from the first step a forecast, how many people we will get on each step and how many people will leave. And we also can get the insights, because as Zina already mentioned, the explainability of the models is very important part. So we are not interested just in the number which somehow arrived at the end, but we also interested in the reason why did we get this number. So what do we use? Which data for the forecast? We use the marketing spends for each marketing channel. Then we also can observe the competitors' activity in the field. We know which ads they are running, how much they are spending, and how much car being registered for particular brands, for example, and also economical factors like inflation rate or employment rate. That's also important, and that also could influence the trend at the end that we have in our time series. Then, as you see this in the middle, there is a forecast model. It could be any model. Some people prefer more linear models if the data are linear. Other people would prefer some more related to trees, because then you can avoid assuming that your data are normal and that they are linear. And then you get the forecast and you get insights. What could be these insights? For example, seasonality. We model it explicitly, and as soon as we know the seasonality, we can give the guidance to the OEM and to the production lines how they should adjust production to the actual demand. We also learn saturation effects. That's something very specific to marketing, because not all marketing channels equally good or equally interesting to us and to our target audience. So, for example, some people prefer to watch TV, other people prefer to crawl around internet, and that's how we can reach them. We cannot reach them from TV, and that's what the saturation effects will give us. Another insight that we can get from this sort of modeling are the lagged effects. That's the early warnings of something being changed in the environment around or inside the funnel. So, for example, if we observe in this given month that we have less visits on the website, we might assume that a few months later we will get less sales. And the last one, the channel contribution. As I said, different channels are not equally good. So some channels, for example, digital advertisement might bring more clients and sell more cars than TV. And that's how that could look at the end. So here we can see that we have the website visitors, and they are driven by digital advertisement and by TV advertisement. And we can observe that the digital TV brings more visitors than TV, which is traditional. Or trends, which I have been already talking about. That's actually the so-called micro trends, when on the weekend there are more people than during the working week, because customers prefer to go on the car manufacturing website on Saturday or Sunday and configure their cars when they have time. Or saturation effects for TV for different sort of advertisement. That's something that we're also getting. And now, when we got all these nice insights, the question is how actually we can utilize it to make our decisions. And here we can actually go in two different ways. The first one would be to manually check our insights and make the decisions. And another way would be to model different scenarios, like multiple, maybe hundreds or thousands scenarios, and evaluate which one scenario will give us the best output. In this case would mean which scenario will sell more cars with less spends. Okay. So what we need for that? In this case, there's a prescriptive part of the project. We ask ourselves the question, if I need to achieve a given target, say if I want to sell 10,000 cars next quarter, how much should I invest and how? Meaning, how I should distribute my budget across different marketing channels and across the time. And how we do that? We provide to the model our time series of target, say sales during the last year or 3 years, and the insights that we learned on the previous step. So we learned seasonality, we provided as coefficients, we learned trends, saturation effects, lag effects, and everything that we have seen. Yeah? And the result of this optimization model would be the optimal budget allocation across marketing channels and across time. So how it has been technically done? So in scikit-learn, there is a very nice opportunity to write your own optimizers and your own functions. So if you are not very happy with kind of, say, linear regression and how it's done, you can run your own with your own formula inside, and then throw some sort of optimizer like a gradient descent to let it convert to the optimal point. Yeah. So you provide a function that you want to optimize, you provide a cost function, and you just let it run. And that's basically how this sort of task was solved here. So for the summary, as I discussed, as I mentioned, the businesses require actionable insights that are far beyond the predictive analytics and exploratory data analysis. And predictive analytics, it's very important and a necessary step to get insights from the data. However, it doesn't tell us which decisions should be taken. That's why we need to go for prescriptive analytics, and it will guide us for the decisions and allow us to evaluate the possible outcomes. So the next step after introducing and getting all this long way of prescriptive analytics would be to build the tools that will help us to search for the optimal solutions in the decision space. So that was it for this project. Thank you. And I'm happy to answer your questions.